Hey guys, this is 5.3 from Calculus. This is derivatives of inverse functions. I want to give you this quick visual to hopefully explain the derivative rule. So some reminders from algebra. If an inverse function has an ordered pair of a comma b, then its inverse function has the exact inverted ordered pair, which is b comma a. Okay. Another thing is that inverse functions reflect over the line of y equals x. So just like the ordered pairs are inverses of each other, there's a nice relationship here between, if you notice in red, the tangent lines. Tangent lines are used to represent the slope of a curve, right? The derivative at that point. So we already said that if f of x has a comma b, then the inverse function has b comma a. But the derivative also has an inverse relationship. So if I want to know the derivative of the inverse function at his x value, the derivative is the inverse, meaning 1 over the original function's derivative at his x value. Okay? So let's take a look at this first question. It says that the function given is x cubed plus x. If g of x is going to represent the inverse and g of 2 is 1, tell me what g prime of 2 is. Okay? Well, let's start off by noticing that they're trying to switch up the lettering on us. We started off with f and then we went into g. Okay? So if they gave us g of x to mean inverse of f, then what I'm really finding, instead of g prime of 2, is the inverse of f prime at 2, which is equal to 1 over f prime at some other x value, which we're going to take a moment to find now. So if here they're telling us that g, which remember g is really just inverse, I know that f of x is going to have some ordered pair, and the inverse of f of x is going to have its reverse ordered pair. So if g, who is the inverse of f, has an x value of 2 and a y value of 1, I know that f of x has the reverse ordered pair, so 1 comma 2. Okay? So back to the formula, if g prime of 2, which is the inverse prime at 2, is 1 over f prime at his x value, it's f prime at 1. Okay, so my answer is going to be 1 over whatever the derivative of f at 1 is. So let's take a moment now and say, okay, if this is f of x, then f prime of x is going to be 3x squared plus 1, and then f prime at 1 is going to be 3 times 1 squared plus 1, which is going to give me 4. Okay, so the answer of f prime of 1 is 4. Then that is going to be the answer in my denominator right here. Okay. Let's go ahead and take a look at another question. Remember, as long as you can fill out these two ordered pairs and this derivative, you should be able to decipher the rest. This next question says, let g of x be this function. Find inverse of g at 2. So here there's a lot less information. We're going to have to do a little more deciphering. The first bit of information I know, I'm going to find the ordered pairs for g of x and inverse of g of x. So inverse of g has an x value of 2. Okay, I don't know the y value, which means that for g of x, 2 must be its y value. Okay, now if I want to know inverse of g prime at 2, I'm going to want to find 1 over original g prime at his x value, which I'm currently missing. So I'm going to have to do a little bit of math to find out what that x value is. So if 2 is the y value of g, I can set g equal to 2 and solve for that x. Okay? So g of x which is x to the fifth plus 3x minus 2, I need that to equal 2, and I'm going to solve for this x. Now, notice that this is x to the fifth. I don't want you to waste your time trying to do algebra. That would be a little too complicated, and in an AP test, they would not expect you to do that. You could almost always solve these questions by doing a little bit of trial and error, starting at 0. So plug in 0, see if it works. Plug in 1, and so on. So if I plug in 0, I get 0 to the fifth plus 3 times 0 minus 2 equals 2. And now these cancel out, so that just leaves me with negative 2 equals 2, which is not a true statement, so this one does not work. Okay, let's try another. Let's try plugging in 1. I get 1 to the fifth plus 3 times 1 minus 2 equals 2. Well, this is 1 plus 3, which is 4. 4 minus 2, which is 2. And that does work, which means that 1 is my x value. So if 1 is my x value here, it's my y value there. Okay, so back to the formula. If I want to do the derivative of inverse of g at 2, that is equal to 1 over the original g's derivative at his x value, which is 1. So now my answer is going to be 1 over whatever the answer to that is. So I'm going to take a moment and solve that derivative. If this is g, then g prime of x is 5x to the fourth plus 3. G prime at 1 is 5 times 1 to the fourth plus 3. This gives us 8. So if this is the answer to g prime at 1, this is what's going in my denominator. Okay. All right, so this next question starts to show us a lot less information. Okay, so we're going to have to start interpreting a little bit more. So they tell me what f of 4 is, what f prime of 4 is, and then they ask us to find the inverse of f prime at 5. So let's start off with what was first given, the ordered pair. I know that for f of x, the ordered pair is 4, 5. Okay, that must mean that the inverse function's ordered pairs are 5, 4. Okay, now they're asking me to find inverse of f prime of 5, which means I'm going to find 1 over the original function's derivative at his x value, which in this case is 4. So my answer is going to be 1 over whatever f prime of 4 is, and they gave me what f prime of 4 is. Okay? Now, whenever I have 1 over a fraction, that just gives me the reciprocal, 3 over 2. Okay? So believe it or not, even though we didn't have a function here, this one was very easy. Let's take a look at this next one. Okay? They started off by giving me what g of 7 is, g prime of 3, g prime of 7, and then they want me to find inverse of g at 3. So again, if you can fill out the ordered pairs and the derivative rule, you should be able to get enough information. So for g of x, my ordered pair is 7, 3, which means that my inverse function has an ordered pair of 3, 7. Okay, first bit of information is the ordered pairs. Then let's go to the derivative. They want me to find inverse g prime at 3, which means I'm solving for 1 over original g's derivative. If 3 was his x value, then we're looking for the derivative at g's x value, which is 7. So I need 1 over the answer to this derivative at 7, which is given to me right here, just like it was in the last question. 1 over a fraction is the reciprocal of that fraction. And we are done. So notice that this question gave me extra information. I did not need g prime of 3. That was there to try and throw you off. Okay, it was extra information. All right, let's take it up a notch for our last question here, and let's do a trig function. We have f of x is sine of x. The x value is in between negative pi over 2 and pi over 2. They're telling us that g is going to represent the inverse of f, so they're switching up the letters on us, and they want g prime of 1/2. Okay, so the moment I see g prime of 1/2, I'm going to go ahead and make that direct translation into that g is really just inverse of f prime at 1/2 is what they're looking for. Okay, so I'm going to have to do 1 over f, the original function, prime at his x value. So let's look at the ordered pairs that we're working with. We know that if g is the inverse of f, we know that the inverse has an ordered pair of 1/2, comma, something. And then the original function, we don't know his x value, but his y value will be 1/2. Okay? So I set up the 2 bits of information, the ordered pair and the formula. Now I need to, like in a question we saw earlier in this video, be able to solve for that x value. So my function is sine of x. That means my function, sine of x, is going to have a y value of 1/2. Okay? Now this next bit of information I'm going to show you is going to come from, in case you need a refresher, pre-cal 5.5, and that is solving trig functions. Okay, so if you need to go back to the YouTube videos in pre-cal 5.5, you can get a recap on that. So the question here is, what x value for sine equals 1/2? Well, whenever we're solving inverse functions for trig, sine and tangent, we look at the right side of the unit circle, and cosine, we look at the top. So if I am looking at the right side of my unit circle, I know that sine is my y values, and my y values are positive on the top in quadrant 1. And I know that at pi over 6, if you need to pull out a unit circle, do so, but I hope if you're taking my AP class, you have this memorized. You have radical 3 over 2, comma, 1/2. So sine is equal to 1/2 at pi over 6. Okay? So that means that this x value right here is pi over 6. And that can get plugged right back into here, to both of these spots. So back to my formula, that means that I'm looking for 1 over the original function's derivative at his x value, pi over 6. So my answer is going to be 1 over whatever the answer to this derivative at pi over 6 is. Let's take a moment. If f of x is sine, f prime of x is cosine of x. So then I need f prime at pi over 6. So cosine of pi over 6, we actually just drew that right here. So pi over 6, the cosine is radical 3 over 2. Okay? So if that is what f prime of pi over 6 is, then that's what's going in my denominator. And 1 over a fraction just gives you the reciprocal, 2 over radical 3. If this is a free response question, you can stop right there. If not, they might ask you to rationalize. Okay? So again, this is a perfectly good answer, but if you did need to rationalize 2 over square root of 3, I do that by taking the radical that's in the denominator, multiplying it top and bottom, and I'd get 2 radical 3 over 3. So we'll call this an OR answer, right? It could be this or this.